What if I told you that scientists have created a computer that uses living human brain cells? Not a simulation of a brain, not artificial neurons made from silicon, actual human neurons. And those neurons have been connected to a computer and taught to interact with video games. They've played Pong, and now they're being used to play Doom. But here's the part that should make you stop and think. Scientists still don't know exactly where the line is between living neural tissue that is simply processing information and something that might actually experience what's happening to it, because these aren't dead cells. They're alive, they're connected, they're responding to stimulation, and they're capable of learning. So the question isn't simply, can we build a computer out of brain cells? We already can. The far more disturbing question is, what happens if those brain cells eventually become something more? The AI energy problem. Artificial intelligence is advancing at an incredible pace. But there's a problem hiding underneath all of it: energy. Modern AI systems require enormous amounts of computing power, and that means enormous amounts of electricity. The bigger the models become, the more infrastructure we need to train and operate them, and the demand isn't slowing down.
New today, residents are pushing back against the rapid growth of data centers for AI across the U.S. amid growing concerns about the environmental impacts on communities.
More jobs may be on the way to one tri-state community. That is, if the residents there want them. One of the world's largest AI companies is aiming to build another data center. But as David Winter reports, there's resistance, including one man who is turning down millions to keep his land.
We've been covering the data center debate in Metro Detroit for nearly a year now, but there are still few local examples of what it's like when they're up and running. One of the most common areas of concern I hear about is the noise that they could emit.
You've seen movies and stuff where they have somebody in a cell torture them with sound.
AI companies aren't just competing over algorithms anymore. They're competing for data centers, processors, cooling systems, and electricity. Old power infrastructure is being brought back online. Companies are making enormous investments in energy. And the fundamental problem is simple. Computers are incredibly powerful, but incredibly inefficient compared with the human brain. Think about what your brain does every second. You see, you hear, you recognize faces, you understand language, you make decisions, you remember things, you learn from experience, and somehow all of that happens using roughly the power of a small light bulb. The human brain operates at around 20 watts. Meanwhile, we're building enormous data centers, consuming massive amounts of electricity just to reproduce tiny pieces of what biological intelligence can do naturally. And that's where things get really interesting. Because instead of trying to make computers more like machines, researchers started asking, why not make computers more like brains? When living cells became computers, the idea isn't completely new. Back in 2008, researchers connected living neurons to electrodes and used their electrical activity to control a small robot. The neurons weren't sitting inside a normal brain. They were growing on a laboratory dish. Yet their activity could be connected to a machine. It was an incredibly primitive demonstration. But it opened the door to something extraordinary. Living tissue could interact with technology. Then another breakthrough changed everything. Scientists discovered ways to take ordinary adult cells and essentially reset them. A skin cell could be transformed into a kind of blank slate and eventually turned into a neuron. That meant scientists didn't necessarily need to extract neurons directly from a human brain. They could start with ordinary cells and create neural tissue in the laboratory, and then things got even stranger. When neurons are grown in 3 dimensions, they can begin organizing themselves into complex structures. They form networks, they develop layers. They begin resembling primitive versions of brain tissue. These structures are known as organoids. And suddenly scientists had something they could never have built from silicon alone: living biological computing material. And if that's not already creepy enough, in 2021, they mysteriously started developing eyes. In 2022, Cortical Labs brought several of these ideas together. They created a system called DishBrain. Hundreds of thousands of neurons were grown on a network of electrodes, and scientists connected those neurons to a video game. First, Pong. The neurons didn't understand what Pong was. They didn't know what a paddle was. They didn't know what a ball was. And they certainly didn't know they were participating in a scientific experiment. Instead, the researchers created a feedback system. When the cells produced activity associated with successful gameplay, they received a more predictable signal. In other words, a normal signal they were always used to. When they performed poorly, or the way the researchers didn't want them to, they received chaotic punishing, or painful, you could say, stimulation. In other words, the scientists created a biological version of reward and punishment. And something remarkable happened. The neural network began adapting. It learned. Not like a human, not like ChatGPT, not like a conscious player sitting in front of a television. But the biological network was changing its behavior based on feedback. And that raises an uncomfortable question. What exactly does it mean for living neurons to learn? Then came the next step. Cortical Labs developed a system called CL1. This time, the biological component was made from roughly 200,000 human neurons. Those cells were originally derived from skin cells, transformed into neurons, and placed onto an array of electrodes. The electrical activity of those neurons could then interact with a computer system, and eventually they were connected to Doom. Yes, the same violent first-person shooter that has been running on computers for decades was now being interacted with by living human neurons. The cells weren't sitting there holding a controller. They didn't have hands. They didn't understand demons, weapons, or video games. Instead, electrical signals from the game were translated into stimulation for the neurons, and the resulting neural activity was translated back into commands, movement, shooting, feedback, reward, punishment, and according to the demonstration, the system was able to learn basic gameplay relatively quickly. And this is where the story becomes much more disturbing, because those aren't artificial neurons, they're human cells. There was controversy surrounding claims about whether these neural systems demonstrated sentience. Some scientists argued that the terminology was being used too loosely and that the claims were being exaggerated. And there is an important reason to be skeptical. The system isn't simply brain cells plus Doom equals conscious gamer. There is a conventional computer involved. There's software analyzing the game. There's an artificial intelligence system determining things like rewards and penalties, and there's a translator between the computer and the biological neurons. In fact, much of the computational work is still being performed by conventional hardware. But something else happened that may be even more interesting. Researchers removed the neurons. They replaced them with random noise, and the learning process stopped, which suggests the biological cells weren't merely decorative. They were contributing something real, something the conventional computer couldn't simply replace with random signals, and that's where the real mystery begins. We tend to assume that intelligence and consciousness are connected, but they aren't necessarily the same thing. A system can solve problems without necessarily experiencing anything. A calculator can perform mathematics. An algorithm can recognize an image. A computer can defeat a human at chess. None of that proves there's somebody inside the machine experiencing the process. So the real question isn't, are these neurons intelligent? The real question is, could they ever feel? And that's a much harder question. Because we don't actually have a perfect scientific test for consciousness. We know what consciousness feels like to us because we're experiencing it. But we can't directly reach inside someone else's mind. We infer consciousness from behavior and communication. And that becomes a huge problem when we're dealing with biological tissue that can't speak. Imagine a person who is completely unable to move or communicate. From the outside, they might appear unconscious. But brain imaging has demonstrated that some patients who were believed to be unresponsive could actually show signs of awareness when asked to imagine specific activities. That illustrates something profoundly unsettling. We can sometimes fail to recognize consciousness even in another human being. Now imagine trying to determine whether consciousness exists inside a microscopic collection of neurons. What would we look for? Movement? Electrical activity? Learning? Responses to stimulation? And what if those signals could be explained in more than one way? A response to harmful stimulation doesn't necessarily prove suffering. A neuron reacting to chaos doesn't necessarily mean it's experiencing pain. The distinction is critical. Because responding isn't automatically the same thing as feeling, and scientists still don't have a definitive way to look at a dish of neurons and say, yes, something is experiencing this, or no, nothing is. There's another fascinating idea behind these experiments. It's sometimes discussed through something called the free energy principle. The basic concept is that living systems tend to act in ways that reduce uncertainty and keep themselves within stable conditions. In these experiments, researchers can essentially create a distinction between predictable and unpredictable stimulation. Success produces a calmer signal. Failure produces chaotic stimulation. And the neurons adapt. That doesn't prove consciousness, but it raises a fascinating possibility. Perhaps some of the mechanisms that eventually produced complex minds are much more primitive than we thought. Maybe consciousness didn't suddenly appear once evolution created a sufficiently complicated brain. Maybe some of its foundations are buried much deeper in the basic behavior of living systems, and if that's true, we may eventually have to reconsider what it means to create something that is merely alive. And this isn't just a laboratory curiosity anymore. Companies are beginning to explore biological computing as a commercial technology. One example discussed in the research is a Swiss company called Final Spark, which has experimented with providing remote access to living neural systems for research. The argument is straightforward. If biological neurons can perform certain computational tasks using dramatically less energy than conventional electronics, then biological computing could eventually become an entirely new computing industry. Think about the implications. Today, we have silicon processors. Tomorrow, we could have computers containing living biological components. And eventually, we could have increasingly sophisticated networks of biological neurons connected to machines. The technology doesn't need to become conscious for this to be revolutionary. It only needs to become useful. But what happens if we keep making those biological systems larger? More complex? More interconnected? More similar to actual brains? That's when the ethical questions become much harder to ignore. Imagine a future laboratory. Scientists grow a three-dimensional human neural network. They connect it to sophisticated sensors. They give it information. They allow it to learn. They connect more neurons. Then more. And more. Eventually, it becomes far more complex than today's systems. At what point would we stop calling it simply tissue? At what point would it become a biological information processing system? And at what point would we have to ask whether it has any kind of subjective experience? There's no universally accepted answer, and that's exactly the problem. Because technology tends to move much faster than our ethical frameworks. By the time we know we've crossed a line, we may already be standing on the other side. For billions of years, consciousness was something we could only observe. We could study it, we could theorize about it, we could try to understand where it came from. But we couldn't deliberately create biological systems and watch them develop in a laboratory. Now we can. We're taking ordinary human cells, transforming them into neurons, connecting them to machines, training them with signals, and watching what happens. And perhaps the most unsettling part isn't that these cells can play Doom. It's that we don't know exactly what the experience of being one of those cells would be, if there is an experience at all. Maybe there's absolutely nothing happening inside. Maybe these are simply biological circuits responding to electrical stimulation. Or maybe consciousness is far stranger and far more fundamental than we currently understand. And if we ever create a biological system that genuinely experiences something, how would we know? What would it tell us? Could it communicate? Could it suffer? Would we even recognize the signs? Because the terrifying possibility isn't necessarily that scientists will accidentally create a superintelligence. It may be something much quieter, something much harder to detect, that somewhere inside a laboratory, inside a dish, inside a machine, something begins to feel. And the game simply keeps playing. Nobody notices. If you enjoyed this video, please like and subscribe to the channel, and don't forget to leave a comment and check out the links in the description below.